We are going to be discussing Leetcode 102 binary tree level order traversal. So the purpose of this video is to provide an alternate solution to the popular videos out there, for example, Neetcodes and AndGoJSS. And the solution I'm going to provide made more intuitive sense to me, so I'm hoping it does for some other people as well. So the problem description is, given the root of a binary tree, return the level order traversal of its nodes values from left to right, level by level. So looks like a very obvious breadth first search solution, but the tricky part is actually providing the result and the output that's required. So let's move on to the diagram. So as I mentioned, it's going to be a pretty simple breadth first search solution, and there's going to be a trick involved. So as we have in the breadth first search, we're going to have a queue, and for this solution, we're going to have a results array. And the trick is, in the queues array, I'm going to store the actual node as well as its level information, which is going to be 0 for the root node. And when I pop a node, what I'm going to do is I'm going to get the level information from here, and in that position of the results area, I'm going to store the node's value. So 3 is part of results now. And let me update the diagram. And when we pop 3, after that, we add its children. So that's going to be 9. And we're going to get the level information from 3 and add 1 to it, which is going to be 1. And for 20, we're going to do the same thing, 0 plus 1. And we're going to continue our breadth first search. We pop 9, and in the first position, we add 9. And since 9 didn't have any children, we didn't add anything to the queue. So we move on to 20. We pop 20, add 20 to the first position. Then we add 20's children, which are going to be 15. And it's going to be the previous level plus 1. So it's going to be 1 plus 1, which is going to give us 2. Similarly, for 7, we're going to do the same thing, 1 plus 1, which is going to give us 2. So just adding the previous level and 1. 7, 2. And in this, now we pop this. And in the second position, we're going to have 15. Since it doesn't have any children, nothing gets added to the queue. We pop this one, and to the same second position, as indicated by the level here, we're going to add 7, and we're going to return it. Now, moving on to the code. Now it's going to be very easy to implement. I'm just going to write down. If the root is null, we just return an empty array. We let the queue initialize the queue to the root, and the root's level is going to be 0, as I mentioned. And the result array, which is going to look like this. And while the queue is not empty, which we're going to write like this. Pop the node and the level from the queue, or shift it. And if there isn't an array in that position, we're going to define it. And then we're going to push that node with the level we just have. And since the problem description is to go left to right, we're going to go left first. And then we're going to queue, push the left node. And we're going to add 1 to the level as I stated earlier. Finally, we're going to return the result. Okay, so something went wrong, obviously. What's the problem? Let's see. Oh, typo. What's wrong now? Oh, oh, this is supposed to be like this. Now it's submitted. Yeah, that's it. The runtime for this is obviously O of n, as it is for BFS.